Can the NCC be found in V1? Evidence from psychophysics. So the relationship between V1 and the consciousness has been discussed in the past. And in summary, its relation is quite complex. And the evidence for and against it is available. But let's examine the case with our triangulation approach. So as I've been advocating, we need to look phenomenology in relation to experimental data, both behavior and also neural activity, and then finally theory. And in this part of the video, we'll focus on the phenomenology. So what we know from the blindsided experiment is that it seems that the first candidate area for the NCC, neural correlates of consciousness, is V1, because blindsided patients are losing the phenomenology due to the V1 damage, right? So it's a natural way to look at it. But what about the phenomenological evidence in the normal brain? So of course, blindsided is a lesion patient. That means that the plasticity and also many different kind of experiential difference might have already contributed to the change of the phenomenology. So we want to know whether the V1 in normal brain also is related to or not related to conscious experience. So let's see if the case is already closed or not in the normal patient, normal subject. So first, phenomenological consideration. Can the process happening within V1, but not area, like LGN or retina, be responsible for the cause of the non-conscious phenomena? So we kind of start with an eliminative kind of idea. Retina and also LGN is almost all out because what you can see on the right side, right now, if you close your right eye, and then if you see it only through the left eye, it's very kind of simple idea. But here in this case, what your right eye is receiving is just a black kind of field, and it is sending the black field information into the brain. However, because the input from the left eye is already strong, what you're experiencing mostly is about reflecting what the left eye is seeing. And if you change it this way or that way, you can see that each of the eye is seeing different input, but at any moment, one of them is more correlated. So that means that overall, one of them is not always correlated with the conscious experience. Or something like that can be happening not only from retina and LGN, but also at the level of V1. That's the idea. And one of the ideas is that at the level of V1, these two input from the eyes converges into one particular neuron. So at that level, this kind of eye of origin information is already resolved. So that's the first part, to suspect that everything from there may be related to conscious. Now let's consider candidate phenomenon, and that's the one that I'll be talking about for the next couple of lectures on orientation dependent after effect under crowding. So let me explain what it is through the demo. What is crowding, first of all? So if you look at this left fixation point here, it to some extent depends on your distance to the display. But I think with the right eye closed, the left eye closed, doesn't matter. But as long as you're looking at here, you probably cannot see the orientation of this grating. And this is now, if you look at that directly, it's clearly to the left. But if you are fixating here, then you may not be able to see it at all. I can't do that if I go a little bit farther and so on. Okay, and then keep on fixating here. But if I go to the next, then it's probably clear that this one is tilted to the left. And this is true, yes. So the same grating presented at the same retinal location, meaning that generating the same response in the retina and the LGN, and most likely in the V1 may or may not become visible or invisible. Visible here and invisible here. Okay, that's the idea of the crowding. And the crowding establishes the orientation of a grating is invisible according to the performance criteria. So if you ask them whether the oriented grating is on the left side or right side or something like that, or whether there was some grating there in the first place or not, that kind of a detection threshold can be determined. That's a performance criteria. And then now let's move on to the part of the critical experiment, adaptation. Okay, so what adaptation means is that if you now ask you to look at this one again, but for extended duration, I'll count for 30 seconds. So just look at this cross, and then don't move your eye, don't blink, and then don't move the body for 30 seconds. Let's go. Don't move your eyes, and don't move your head, body. Just focus on this fixation cross. Okay, and then I'll ask you to say whether you see the grating at that location afterwards. And if you didn't see it, that's fine. If you see it, just remember how, faint or how strong the grating is. Okay, 3, 2, 1, 0. Okay. Then another one, it's called a top-up procedure. Another 5 seconds of fixation. 5, 4, 3, 2, 1, 0. So I don't know if that worked or not for you, but the idea is that if you fix it on here for a while, and then you are shown with this target that is the same orientation as the adapted grating, then it would be difficult to see, more difficult to see compared to this different orientation grating at the same location. That's the idea of the adaptation experiment. So the upshot of this experiment is that crowded, meaning the invisible, and the single, which is visible grating, produce the same level of adaptation. Here, a y-axis is the contrast threshold elevation. So that means that how difficult it is to see the stimulus at that location, depending on the orientation. So here on the left side, x-axis explains when the same orientation is presented, you need 6 times more strong stimulus than before, at the before the adaptation. If the stimulus is different orientation, then because of the general adaptation, it becomes more difficult to see it afterwards. But just like twice as strong stimulus needs to be there for the detection. And then this is a case of a single stimulus, so it is totally visible. But if it's totally invisible by crowding the stimulus, still you get the very, very strong effect. So it's like 5.5 here. And because of the error bar, it's not the difference between single versus crowded condition, and the same goes for the different things. So that means that regardless of the visibility, the adaptation was the same. Okay, but here, if you're not really used to this kind of experiment, it's very complicated in terms of the logic. So I'll try to untangle this, disentangle in the next. So, but you need to, be aware that, that the logic is not super straightforward. So what, right? Okay, if you thought that, you don't really understand this in idea, then that's actually okay at this stage. So in summary, what I wanted to do in this video is that the V1 seems like a good starting point to discuss as the possible location of NCC. based on the blindsided patient. And then we started to consider orientation-dependent after effects under crowding. And I showed that the phenomenology of crowding and phenomenology and those empirical results of the after effects. But at the end, we are not so sure what does it tell us about the issue of V1 and the consciousness, and that comes in the next video.